Functions. Functions are something you've used your entire life, and now we're just quantifying them with some math. Very specific math, so let's run through how this is. What we should know about functions initially is they are a type of relation, a very specific type of relation. And what we know about functions is this. A function, in its most general sense, is if we have an input, it goes into the function, and that function gives us an output. And you might remember something like this from like first grade, where we would have like the input-output box. So if I had a little box here, and my box on it said +5, what I could do is I could put something into the box. Let's say I put 4 into the box, and what I got out from 4 was 9. If I put 3 into the box, I got 8. If I put 9 into the box, I got 14. That was a function. So some input that then is acted upon by a function and then gives us an output. What I kind of want you to notice about functions right now is this. Is there any number that I could put into the function and get 2 different outputs? Could I put 4 into my function and get 9 but also get 10? No. So this is a unique thing about functions to kind of hold on to remember, is that according to functions, each input has one unique output. Okay? Each input has one unique output. There cannot be an input that gives you 2 different outputs, because then that's not a function. So let's look at function notation. Function notation is slightly different. What we have here is f of x equals 12x. It should look sort of familiar though. It should look a little bit like this. Y equals 12x. And it does the same things for us. So here we've got our input, here we've got our output, here we've got our input, here we've got our output. Let's talk about this piece right here. This is said as the function of x, or more generally what we do say is f of x. Now for functions, it doesn't have to be f, it doesn't have to be x, but in general we use f and x. What it could be something as simple as h and m. It could be g of f. Anything you want to use for variables are possible, but the general thing that we use is f of x. And what this says in f of x is that this is our input, and whatever this is, we're going to put it in there to find out what our output is. So let's look at how that works. If we're finding the value of a function, so if we just read this, f of 11 if f of x equals 1/2 x plus 5. Don't get intimidated. So this says f of 11. That means that my input is 11. So I could rewrite this as f of 11 equals 1/2 x plus 5. f of 11 equals 1/2 times 11 plus 5. Notice that my input here just was put in for the input on the right side. And now I'm just doing the math. So the math tells me that f of 11 equals 1/2 times 11 is 6.5. No, 5.5. 5.5 plus 5. f of 11 then equals 10.5. 10.5. So I found the value of that function. And the twist on this is that you have an understanding that when it says f of 11 equals 10.5, if we look back at the original function, if we just look at the original function here, what we know is 2 things. Number 1, we knew what the input was, and now we knew what the output was. So we know the input was 11, and we know the output for 11 was 10.5. Let's take it another step. So for a function table, this is a way that we represent functions. So when we represent functions in a table, we have 3 columns. And what we know in those 3 columns is we've got the input, we've got the function, and then we've got the output. Now, other ways to label this. So we know that the input here is x. The output here in this situation is f of x. And we know this is the rule. We also should know that x is our independent variable. The output is our dependent variable. So whatever value, this can be any value, but this value can only occur based on what that value was. Now for finding the inputs and the outputs for this, we get to choose, and I'm going to choose just 5 kind of standard inputs and outputs: -2, -1, 0, 1, and 2. And what that does for me is it's going to give me a bunch of order pairs that are right around the origin. So it makes it a little bit easier for me to graph. And I'm going to take these values and then put them into my rule. So I'm going to have 7 plus 3, use my green here. Let's see if we can do this in a colorful fashion. 3 parentheses -2. 7 plus 3 parentheses -1, my input. 7 plus 3 parentheses 0. 7 plus 3 parentheses 1. 7 plus 3 parentheses 2. Now let's figure out what the outputs are. So I've got 7 plus 3 times -2 is -6, so I have a 7 meeting a -6, which leaves me +1. -1 times 3 is -3. 7 and -3 gives me 4. 3 times 0 is 0, so that's 7. 3 times 1 is 3, plus 7 is 10. 7 plus 6 is 13. And now we've created our function table for that function. We could then graph that. We could set that up in a separate table to demonstrate what that is. But that's how our function table will work. We have input, rule, then output. Then let's do a fantastic word problem. What I've got here is, in a recent 82-game season, Dwight Howard of the Orlando Magic, ooh, this is a little old, averaged 20.7 points per game. His approximate total points per game scored, P of G, is a function of the number of games he played, G. So what's the independent variable? What's the thing that we don't know how many of these happen but make us or give us the total points in the end? It is the number of games. So number of games tells us the independent variable, and that's going to be G. The dependent variable is how many points he scored in total. So total points, and that's based on how many games he plays. And they told us that total points would be P of G. P of G. So let's now write the function. So the function in our function notation is P of G equals, something times G. Let's go back in the problem and look. In an 82 game is it 82? 82 games, 82 times, no. Dwight Howard averaged 20.7 points a game. So 20.7 per game. His approximate total points is a function of the total number of games he played. Okay, so we have a function. And now we have, how many points did he have after 18 games? Okay, so after 18 games, we could rewrite this. So let's just write this as P of G equals 20.7 G. P of 20.7 equals, no, that's not my number of games. P of 18 equals 20.7 times 18. There. Now I think when we get to the end of this, you're going to see how the function notation kind of helps us in this. Let's do some side math here. 20.7 times 18, 56, 5, 16, 0, 1, 7, 0, 2. Oh, that was a 6. 6, 12, 7, 3. 1 decimal place, 1 decimal place. So I've got P of 18 equals 372.6 points. Now the nice thing about function notation, when I look at my function now, what I know is this value was for that many games. In 18 games, we would guess that he averages about 372.6 points. Because it's an average, that tenth digit is okay, because no matter what, it doesn't necessarily have to end up as an even number. All right, let's go to the review. So on the review, we've got a function. Let's not forget what a function is. So a function is something that has an input with a unique output, a series of inputs and outputs that go together. We know that this is said as f of x. We know what an independent variable is. It's the one that can change. It can be anything, can be anything, and that's usually our x. And our dependent variable depends on x, and that is y. Don't forget what a function table is and how we solve for functions. Good luck.